802.11 Network Architecture, Part 2. Now in the previous video we learned the method by which wireless stations locate wireless access points. Well, in Part 2 we're going to learn once the stations have located a wireless access point, how do they actually connect to it? Meaning now that they've found it, how do they establish a connection so they can actually transmit and receive data from the wireless station to the wireless access point and vice versa. That is done through a process called authentication and association, which we'll learn about in this video. And we'll also learn about the power management features of the wireless stations and the wireless access points as well. So put on your wireless network administrator hat and let's start off by learning what it means to be authenticated and associated to a wireless access point. And we'll do that by bringing up a whiteboard. Authentication is essentially the process that's used to verify the identity of the wireless client or the wireless station. Now, note that I did not say user. This is the process to identify the station and not the person who's logged on to the station. And authentication is the very first step that's required for the wireless station to connect to the wireless access point. So this is step number 1, authentication. Assuming that authentication has been successful, then step number 2 is the wireless client, the wireless station, attempts to associate with the wireless access point. And once the association is successful, the wireless station will then be able to transmit data through the wireless access point. So to ensure that we've got a solid understanding of the authentication and association process, let's bring up an illustration of the process that the wireless station goes through for authentication and association. Now, as we learned in part 1 of the video, the very first thing that a wireless station will actually have to do is simply find a wireless access point. And again, it does that by broadcasting a probe request frame on every channel. So it's broadcasting out, hey, anybody on this SSID, anybody out there? And if there's a wireless access point within range, it'll respond with a probe response frame, which again will contain capability information of the wireless access point, its SSID, etc. Now at that point, once it's found a live target, if you will, once it's found a wireless access point, it says, oh, cool, now I want to authenticate with you. So the next thing is the station will send out an authentication request frame. At that point, the wireless access point will send out an authentication response, and assuming that the authentication has been successful, the wireless station will then send out an association request frame, and then at that point, the wireless access point will send out an association response frame, and if it's set to allow, the wireless station will then at that point be able to transmit data through the wireless access point. So again, the first step in the connection process to a wireless access point is authentication. The next step is association. Now, something to take note of, though, is that a wireless station can actually be authenticated with more than one wireless access point at any given time. However, it can only be associated with a single access point at any given time. So by being authenticated with multiple wireless access points, that essentially allows the wireless station to be pre-authenticated, which allows for roaming to be much more smooth and much more seamless. If it's the user's walking down the hall with their laptop and they've already been pre-authenticated with an access point, then everything happens much more quickly and much more smoothly as a result. Also, most wireless access points will have a table listing the wireless stations that have successfully established an association with that wireless access point. Let's take a look at the wireless access point that I'm using for this example and see if we're associated here. So I'll bring up Internet Explorer and connect to a wireless access point via its little built-in web server. So type in the password here. So for this particular Proxima wireless access point, we're going to look at its table by clicking on the monitor button, and from here we're going to scooch over a little bit, click on the station statistics tab, and we see right at the top here it says, hey, this tab displays the information related to associated stations and WDS links, meaning bridges. So if we scoot down here, we see that there is one station that has successfully established an association with this wireless access point. We see its MAC address, its IP address, the interface, what type of wireless connection this is, meaning station or bridge, the protocol being used, signal to noise ratio, and basically the last time that a frame was sent. TSLF is time since last frame was received from the associated station or the bridge. And there we go here. So let's close out of here, get back to our whiteboard. Now, there are typically three methods that are used for authentication within a wireless network. Let's bring up another whiteboard and learn about those three methods. Now, the IEEE 802.11 standard specifies two methods of authentication for a wireless network. The first method is open system authentication, and the second method is shared key authentication. And another method, which is the 802.1x authentication method with the Extensible Authentication Protocol, or EAP, is an additional authentication method which is more secure. Let's learn about the open system authentication method by going back to our authentication overview whiteboard. Now, first off, open system authentication is the default authentication method for wireless access points and wireless stations. And I stress default because this is not a secure method of authentication. Open system authentication uses null authentication, meaning that no usernames or passwords are transmitted in order to authenticate. No encrypted text, nada, nothing. It's an open door policy. The wireless station knocks on the door of the access point, and the wireless access point just opens it up, says, sure, come on in, here's the party, transmit your data. So what happens with open system authentication, when that is configured on both the wireless access point and the station will, as we learned, find a wireless access point either by probing for one or for listening for one, finds a wireless access point, sends an authentication request to that wireless access point. The wireless access point responds with an authentication success. So you just knock on the door. Hey, can I come in? Sure, no problem. Then at that point, the wireless station needs to associate by sending an association request, and then the wireless access point sends a success association response. Now, with open system authentication enabled on a wireless access point, a wireless station can connect to any wireless access point that has open system authentication enabled on it, even if it has a different SSID. So again, the wireless station can connect to a wireless access point within range if it has the same SSID or a different SSID. So let's take a look at now how a wireless station would actually connect to a wireless access point that is configured for open system authentication. So I'm going to do that by bringing up my network connections folder on my Windows XP computer here. I'm going to double click on my wireless network connection. Then I'm going to click on the option View Wireless Networks. So currently I'm connected to Nugget Lab, which is using WPA security, and the SSID has been disabled. The broadcasting of it has been disabled. So what I'm going to do right now is refresh the network list and try to find another wireless network within range, and we have one right here called Lab Unsecured Wireless Network, meaning that it's using open system authentication. So what I'm going to do right now is click on this connect button to try to connect to the lab. Yes, I want to connect to it even though it's unsecured. Thanks for the warning. I appreciate that. Drum roll, please. And it's acquiring a network address, so this is a good sign here. And we are connected. Yeehaw! Let's close out of here. Go to the properties of my wireless network connection. Click on the Wireless Networks tab. And we've automatically been added to this Lab WAN, meaning that I had not previously added Lab as a preferred wireless network into this computer. When we viewed Lab from the list of available networks and clicked on the Connect button, and once we established that connection, Windows XP automatically added Lab as an entry to these preferred networks. And it automatically configured Lab as well. So we can view the configuration settings by selecting Lab and then clicking on Properties. So it automatically entered in the name of the SSID, which is Lab lowercase, and it automatically configured the network authentication type to Open System Authentication. Also, if you remember, when we clicked on the Connect button, we got this little stern warning saying, hey, you sure you want to go ahead and do this because this Lab wireless network is unsecured. And we said yes, but we see the result of that right here as well. Data encryption has been disabled, meaning that web encryption is not being used on this wireless network, and as a result we didn't have to enter in a network key to enable web encryption for protecting the data that's transmitted between the wireless station and the wireless access point. So we can use open system authentication with or without data encryption. So in our demonstration we saw how to connect to a wireless network without data encryption. However, if data encryption was enabled on the wireless network, we would have been prompted with a second dialog box asking us to enter in the network key that was being used by that wireless network, meaning the wireless access point that we connected to. Now, what I want to make clear here is that if you use open system authentication in conjunction with data encryption, that is not a form of forcing authentication or requiring an authentication method. When you use open system authentication with WEP, what happens is the authentication process still proceeds using null authentication. No username, no credentials, no passwords, nothing. And then the association process takes place. So step 1, authenticate using null authentication. Step 2, associate. Step 3 is verify the network key that's used for WEP encryption. So if we're using open system authentication with WEP, the WEP key is only used for encrypting data once the wireless station has been authenticated and associated. So remember just a second ago I said that if the lab wireless network was using WEP encryption, we would have first connected to the lab network, and then as a second step we would have been prompted to enter in the network key that's used for WEP data encryption. Now at that point, if we didn't enter in the correct WEP key, we would not be able to transmit data on this wireless network because it's required that data encryption be used. So in that sense, WEP keys can act as a form of access control, because if the wireless client doesn't have the correct WEP key, the wireless access point will not allow them to transmit data between that station and the wireless access point. Now, the second form of network authentication that's supported by the IEEE 802.11 standard, again, is shared authentication. We also see Wi-Fi protected access, which is used in conjunction with the Radius server, which we'll learn about in a few minutes, and Wi-Fi protected access PSK, which means pre-shared key, which means we'd manually type in the key that's used for encryption in conjunction with Wi-Fi protected access, or WPA. But the 802.11 standard, right out of the box, only supports open and shared authentication. Now let's bring up a whiteboard and learn about the shared authentication process. And we'll bring that up right here. Well, in a nutshell, shared key authentication is a method for verifying the identity of the wireless station by using a string of numbers or text. And the string of numbers or text is referred to as the WEP key. And the WEP key can either be a passphrase, like you type in a string of numbers or text, or it can be a hexadecimal equivalent of a passphrase. And the length of the amount of characters you have to enter will vary according to the level of encryption that you use. And we'll learn more about that in the security video in this exam pack. So first off, in order to use shared key authentication, both the wireless access point and the wireless station must be configured to use WEP for data encryption. And then the second step is to configure both the wireless access point and the wireless station to use the exact same WEP key. And as we just saw in the interface a moment ago, the wireless station would also have to be configured to use shared key authentication instead of the default of open system authentication. So once those components have been configured on the wireless access point and on the wireless station, the process of shared key authentication is as follows. First off, the station finds a wireless access point and then initiates an authentication request. Now at this point, after the wireless access point has received that request, it's going to issue a challenge to the wireless station. And the challenge is simply a randomly generated alphanumeric phrase. So it's just some letters and numbers that have been just randomly generated, and that is referred to as a challenge. And this challenge is sent to the wireless station. And what the wireless station will do is it'll take this challenge and it'll encrypt the challenge by using the WEP key that it has been configured with, and then it sends that challenge, this encrypted challenge, back to the wireless access point. And at that point, the wireless access point will decrypt the encrypted challenge using its key. So if they both have the same key, the wireless access point will be able to decrypt the encrypted challenge with the matching WEP key. So if the wireless station's WEP key is the same as the WEP key that's used on the wireless access point, the wireless access point will in turn authenticate the wireless station. At that point, the wireless station will then initiate an association request, and the access point will say, yes, you can associate with me. Now, if the WEP key that the client has used is not the same key that the wireless access point has, then at that point, the wireless access point will not authenticate the client. So that way, since it can't get authenticated, then it can't associate either. Now, on the surface, it would seem that shared key authentication is much more secure than open system authentication. Well, that's not really the case. If you use open system authentication in conjunction with WEP to secure the wireless data, that is actually more secure. Yes, you heard me correctly. That is more secure than using shared key authentication. And the reason for this is that the challenge that is transmitted using shared key authentication is actually transmitted in plain text. And the wireless access point receives the same challenge text encrypted with the wireless station's WEP key. So this means that a hacker can use a network protocol analyzer to see and capture both the plain text challenge and the encrypted challenge. By having both of these components, it is much, much easier to use many available software programs out there to derive the WEP key much faster, much more easily than by using open system authentication in conjunction with WEP to encrypt the wireless data. So shared key authentication may be a big showstopper for implementing a wireless LAN in a company network. However, there is another method for wireless authentication. That other method is using 802.1x standard in conjunction with EAP. Let's bring up another whiteboard and learn about this authentication method. 802.1x is a relatively new IEEE standard for authenticating users on a wireless network. And this is used in conjunction with the Extensible Authentication Protocol, or EAP for short. And what 802.1x allows us to do is to authenticate the user versus the station. And that is done in conjunction with what's referred to as a radius server. So you can think of the radius server as essentially as a gatekeeper. The wireless access point will forward the authentication request to the radius server, and the radius server will in turn look at the user credential database, which is typically your Active Directory database if you're using Windows Server 2003 or Windows 2000, or your LDAP directory or your NDS directory. Whatever the case may be, whatever directory service that you're using for storing your user credentials, the radius server will look up the user credentials in that database, your LDAP database, for example, to verify the user credentials. And if everything is up to snuff, the radius server will tell the access point, this is a good person, they've got the credentials, you can let them in. So that's the basic overview of the process. Let's look at the nitty-gritty of this process step by step here. So again, the very first thing that the wireless station is going to do is issue an authentication request to the access point. Now at this point, the access point will, lots of points there, no pun intended. The access point will issue an EAP identity request. And EAP again stands for Extensible Authentication Protocol. And it's extensible in that you can plug in different types of authentication protocols. So for example, you could use digital certificates as a means for authenticating the user. So once the wireless station has received this EAP identity request, the station that is configured to authenticate using 802.1x and EAP will issue an EAP identity response to the access point. Now at this point, the wireless access point, the AP, will bundle up that EAP identity response and forward that to the radius server. The radius server will then issue a radius access challenge, and right now at this point here the AP will simply act as a go-between. All this information from the radius server to the client will just pass through the access point. So the radius access challenge will go right through the access point to the station, and this challenge is protected and encrypted by using the protocol that is added into EAP. So the challenge is not sent in the clear as it is with shared key authentication. The wireless station will then submit a radius challenge response. Again, it's going to pass through the access point and be forwarded to the radius server. And if the radius server is able to decrypt the challenge and be able to verify the identity of the user, then the radius server will say, yep, you're good to go. We'll forward that information to the access point. The access point will then forward an EAP success to the wireless station, and then at that point the wireless station can establish an association with the wireless access point. So the radius server will solve these two problems. Once the user has been authenticated, what will happen is the radius server will generate a dynamic session key, meaning that you don't have to enter in a WEP key. That is taken care of by the radius server. It's a dynamically generated session key, meaning that each time the user logs on to the wireless network and is authenticated, they'll get a brand new WEP key to be used for that session. So it's used per session. And because you get a brand new key for each session, it's less likely, not impossible, but it's less likely that a hacker will be able to capture enough packets to derive what the WEP key is. And right out of the box, Windows XP supports wireless authentication by using 802.1x. And we can see this by going to the properties of our wireless network connection. Right-click on it, choose Properties from the menu. Then go to our Wireless Networks tab. I'm going to select the wireless network that I'm currently connected to. Click on Properties. And I have connected to this wireless network by using WPA with a pre-shared key, meaning I had to manually enter in the pre-shared key that's used by this wireless access point. Now I can use WPA with a radius server by choosing WPA, and if you notice, it's very, very subtle. Let me switch this back. Down here where the mouse pointer is, it currently has deselected the key is provided for me automatically. However, when I choose WPA, it automatically chooses that option because by choosing WPA, that requires the authentication be done by using 802.1x or by using a radius server, and we can choose the EAP type, which as a default is a digital certificate. And so it makes the authentication more secure, and you get dynamically generated keys, which in turn makes the wireless networking more secure. So those are the three wireless authentication methods that are available. Now, in addition to authentication, power management is also a very important component, because what happens if we have a wireless station that is running on battery and then occasionally goes to sleep, or we want to configure the wireless network adapter to go into a low power management mode? What's going to happen to the wireless data that's trying to be sent to that wireless station while it's asleep? Well, first off, let's take a look at the properties of our wireless network adapter by going into the Network Connections folder. Right-click on it, choose Properties, and we're going to click on the Configure button here. And let's go to the Advanced tab. And if you notice here, there is a power save mode, and currently is disabled. That means that this wireless network adapter is running in continuous aware mode, meaning that it's always running, it's in an active mode, it's always getting power. And continuous aware mode is also referred to as CAM. Now, if we choose to enable this functionality, to enable the power save mode, this is technically referred to as power save polling, or PSP for short. So again, when power save mode is disabled, that means that the wireless network adapter is running continuous aware mode. It's always receiving power. It's always listening for beacons. It's always up and running, and it's active. When we choose to enable the power save mode, then we configure the wireless adapter to power save polling, which allows the operating system, in this case Windows XP, to place the wireless network adapter into a low power state, which helps to conserve battery power for laptops that are using the battery power instead of being plugged into the AC power. So let's close out of here now and learn what the access point and the wireless station will do when it is in power save polling mode. how is it going to receive packets while it's asleep, basically? Let's bring up a whiteboard and learn about that. And there are two different power save polling modes, one for a BSS and one for an IBSS. We're going to learn about the power save polling mode for a BSS first. So when power save polling mode is enabled for a wireless network adapter, the station goes to sleep, meaning the wireless network adapter goes to sleep for short time intervals. So the transceiver, the radio, the whole bit, it's going to sleep, and as a result it's not drawing battery power, that precious battery power from the battery on the laptop. And so when the station goes to sleep, it doesn't just go to sleep. It tells the wireless access point saying, hey, you know what, I need a couple of snoozes here, a little bit of shut-eye. I'm going to go down and out for a little bit here, and I want to let you know about it. Cool, the access point says, thank you for telling me about that. And the wireless access point marks that station from that MAC address as in power saving polling mode, or it's gone to sleep for a little bit. At that point, what will happen is the wireless access point will buffer or queue up any packets that are destined for that wireless station that is in sleep mode. Now, to understand step number 4 in this process, you'll have to remember back to the Network Architecture Part Number 1 video, where we learned that within a beacon it contains a timestamp, and the wireless station uses the timestamp to synchronize its clock with the clock that's on the wireless access point. And that is used to know when a wireless access point transmits a beacon that contains a traffic indication map. And if you remember, a traffic indication map contains the identity of which wireless stations are in power-saving mode that have data buffered on the wireless access point. So what the station will do is that it'll wake up the transceiver, it's going to wake up the wireless network adapter just before the access point sends a beacon that contains the TIM, the traffic indication map. And then I'll look at the map again, look at this, the contents of this beacon, says, okay, great, I've got data waiting for me, data buffered on the wireless access point, and it will then request that that data be sent. The access point says, cool, great, glad you had a little nap, here's the data. And then the station says, wait a second, I'm not done with my nap yet, I want to go back to sleep. So while the station is running in this power save polling mode, it just keeps repeating this process. It goes to sleep, wakes up just before the beacon is sent, looks in the beacon to see if it has any data buffered. If it does, it asks for that data. If it doesn't, it goes back to sleep. So it goes to sleep, wakes up, goes to sleep, wakes up, goes to sleep, wakes up. And as a result of this, a little more traffic is sent than normally would be if the client was running in CAM mode. And so it's a bit of a fine line here. You save battery power, but more traffic is sent as a result of being in this power save polling mode. So this is how power save polling mode works when our wireless network is arranged in a basic service set, a BSS. But what if we don't have an access point and we're using an IBSS arrangement? Let's bring up a whiteboard and learn about that. So in an ad hoc network or an IBSS, the basic gist of this is that it's the responsibility of all wireless stations to buffer packets. So there's no wireless access point. The shoulder of buffering packets falls on all the stations that are in the ad hoc network. So we just learned that in a BSS, a wireless station has to wake up prior to the access point sending a beacon containing a TIM to find out whether or not it has data buffered on the access point. Well, in an IBSS, because we don't have an access point, the counterpart to that is called an ATIM, or an ATIM, the Ad Hoc Traffic Indication Map. And what this is that it's a window of time in which all stations have to wake up before an ATIM is broadcast out, is transmitted, so a station can find out whether or not it has packets buffered on a station or stations. So when a wireless station is running in power save polling mode in an ad hoc arrangement, all of the stations are absolutely required to be awake for all beacons that are transmitted. They can't be asleep for more than one beacon period, and this is required so that they'll be awake prior to the ATIM window beginning. So first off, the way this works is we have some wireless stations running in power save polling mode. And as I just mentioned, these stations have to wake up prior to the beacon period beginning, prior to the window of time called the ATIM window starting. And then there will be a designated station, a designated wireless station that will transmit the beacon. And the beacon will contain the ATIM frames stating which station or stations have data waiting for them. So the wireless stations will wake up, get these ATIM frames, they'll see whether or not they have data buffered on another wireless station or stations for them. Let's say that they do find that there's data buffered for them, so a station or station has data to send to that station that was asleep, taking a little nap. So again, this is all done during the ATIM window of time, this window of opportunity really. Hey, this is your time to get your data. The stations will request that this data be sent. The data will be transmitted to those stations, and then the clients go back to sleep. And then this process repeats itself again. So the clients go to sleep, they wake up prior to the beacon being sent, they find out whether or not there's data buffered on other wireless stations, the data is sent to them, and then they go back to sleep again. So in an ad hoc environment, it's really a community effort. We're all working together here because there's no wireless access point. So with that brings us to the end of this video. Let's bring up our whiteboard and do a recap of what we've learned here. So we start off by learning that before a wireless station can transmit data on the wireless network, they first must be authenticated. So a wireless station starts off by not being authenticated and not being associated. So step number one, they need to be authenticated, and once they're authenticated, they then have to be associated. So that's step number two. So once they've been associated with a wireless access point, then they can transmit data wirelessly. And we learned that the 802.11 IEEE standard calls for two methods for authentication, and they are, that's right, open system and, you got it, shared key authentication. And then there's a new IEEE standard called 802.1x authentication, which is a more robust authentication, provides for dynamic web keys, and the challenge that's used for authenticating the wireless client is not sending the clear text, it is encrypted. And we just finished off by learning about the power management features in a wireless network and how they differ when our wireless network is organized in a BSS and an IBSS. And the key differentiation is that within a BSS, the wireless stations will wake up and listen for a traffic indication map that is sent by the wireless access point, informing them that they have data buffered on that wireless access point. However, in an ad hoc environment where there is no access point, it is the duty and the responsibility of all the stations to buffer packets that are destined for stations that are asleep. And the sleepy stations will wake up just prior to the ATIM window beginning to find out whether or not they have data buffered for them on other stations in that ad hoc environment. And I hate to say it, but that brings us to the end of this video. And I hope that this video has been informative for you, and I'd really like to thank you for viewing.